Hi everyone, welcome to Civil Engineering NATED e-learning. My name is Justice Tsehla. Our subject today is Building Science N3. We are going to treat this question 7 here. Is the framework. We are told to fully label the space diagram and redraw it to a scale of 1 centimeter equals to 0.5 and indicate the nature of the forces. Then after we calculate the magnitude of the two reactions, RL and RR. And then the last part, we draw the force diagram to a scale of 1 centimeter equals to 2 kilonewtons. So people, this is our force diagram. So we are told to redraw this space diagram up to scale. Before you redraw this space diagram, it's very much important to know or to identify what is it that is missing from this space diagram. If you can check, for you to calculate these two reactions, you need to have your distance, the span between the two reactions. So we are going to find the span between the two reactions by redrawing this space diagram up to scale, the given scale. So ladies and gentlemen, our given scale is 1 centimeter equals to 0.5 meters. So this given scale here, we are going to apply it here. So 1 centimeter on your ruler equals to 0.5. So add 1 on your ruler equals to 0.5, add 2 equals to 1, add 3 equals to 1.5, add 4 equals to 2, because we are given the span of 2. So now we are done with this part. So now we are going to draw this. I'm going to show you how to draw this space diagram with your set squares. We are going to use only two angles, the 30 and the 60, with your set square. This angle here, it's 30. If you can check, it's 30. And then this one, it's 30. This one, it's 60. This is line 60. This is our line 60 as well. This line is line 60. This angle is 30. This angle is 30 as well. After you're done with your angles, and then you write your point loads, the given point loads. This one, 6, 10, and 5.1, and you label your members B, G, H, I, C, E, D, J, F, A. Then now your space diagram is complete up to scale. Then you measure the distance between the two reactions. The distance between the two reactions. It's 4.7. If you can check, you can see it's 4.7. From 0 to 4.7, the span between the two reactions. Then you calculate your RL, and then you say RL times the distance, which is 4.7, equals to 10 times 2.35. 10 times 2.35. And then you move to your next force. It's 6 times the whole distance, which is 4.7, is this one. And then 10 times 2.35 is 23.5, and then 6 times 4.7 is 28. And then you add the 2, it's 51.7. You divide it by 4.7, then it's going to give you 11 RL. So now let's calculate our RR. Our RR is 10 times 2.35. 10 times 2.35, because the force is in the middle. 10 times 2.35. And then 5.1 times the whole distance, which is 4.7. And then the answer is 23.97 for 5.1 times 4.7. And then 10 times 2.35 is 23.5. You add the 2, it's 47.47. You divide it by 4.7, and then your RR is 10.1. kilonewtons. So now let's draw our force diagram with the given scale of 1 centimeter equals to 2 kilonewtons. Then now let's move clockwise direction. Now we draw our force diagram. We are going to draw our force diagram with the scale of 1 centimeter equals to 2 kilonewtons. So let's move clockwise direction. From E to A, there is a force between, which is 11. So we take that 2 kilonewtons, we divide it by 11. It's going to give us 5.5. From E to A, it's going up. The force is going up. Okay, fine. From E to A, there is a force here, which is 11, and then we divide it by the scale. The scale is 2. 11 divided by 2, it's 5.5, and then the force is going up from E to A. This is our E. You put your E anyway, and then you move up with 5.5. This is your 5.5. This is your A. Then from A to B, there is a force that is going down with the force. The force is 6 kilonewtons, and then the force is going down. So you're going to say 6 divided by 2, it's 3. Then you go down by 3. Then from A to B, your last point was A, and then you're going down with 3. It's here. Then you put your B. From B to C, it's 10. You divide it by the scale, the given scale. The scale is 2, and then it's 5, and the force is going down. So it's 5. From B to C, you're going down by 5. This is your B. You go down by 5. You can see it's 5. And then you put your C. And then from C to D, it's 5.1. 5.1, you divide it by 2. 5.1 divided by 2 is 2.55. From C to D, this is your C, this is your D. Check. And then it's 2.55. This is your 2, this is your 2.5 and 2.55. Then you put your D here. Before you construct your members, check the horizontal on your space diagram. This is our horizontal B, horizontal C, and horizontal E. So we construct them on our force diagram. It's only 3 horizontals on our space diagram. It's horizontal C, you construct the line, and then horizontal E, you draw your line, horizontal B. Then now on our force diagram, let's construct our line AF. If you can check our line AF, it's vertical, and then the F is at E. So because the line is vertical here on our force diagram, FE, we need our AF, and then F is at E. So you put your F here is at E. You put your F here because it's at E. So it's our line AF. From our last point F, let's construct our line FG, and then the G is at horizontal B. Don't forget that to use the angle, the set squares. So your FG is 60 degrees. So we are going to construct line FG with the angle, the set square of the angle 60. From F to G, we construct our line FG, and then the G is at horizontal B with the angle of 60. This is our G. GB, it's horizontal, and then FG. Now check from our last point G, we need to construct line GH, and the H is at horizontal E. From our last point G, let's construct our line GH, and then the H is at horizontal E. This is our H. It's HE and HG, and then check. HE is horizontal, HE is horizontal, and then check your GH. Our last point is H. Now let's construct our line HI with the angle of 60. This angle is 60. Don't forget that I is at horizontal C. We need our HI, but I is at horizontal C. From our last point H, we need our HI, and then I is at horizontal C with the angle of 60. This is our I. It's I, C, CI is horizontal. Check. IC is horizontal. Then from our last point I, we need to construct our line IJ. Line IJ, it's 60 as well. It's 60 degrees. Don't forget that our J is at vertical D. Our IJ is gonna give us vertical JD. Then from I, you construct your line. Then here it's our J, IJ, and then it's gonna give us JD, the vertical JD. This is our line This is our line JI. Then you put J here. Then our last point is JD, the vertical. We already constructed it. It's J, it's JD, it's vertical. JD, it's vertical. Then you rub all your horizontal lines. You rub the overlaps. Then this is our space diagram, force diagram. So now this is our table. This is our members. So now we are going to identify our magnitudes and the natures. So let's start with this row, the magnitude. Let's start with CI. This is our CI. You go to your your force diagram. You check the CI. You measure the CI. It's 1.4. CI, it's 1.4. Then you multiply it. We multiply it by the scale, which is 2 kilonewtons. It's 1.4 multiplied by 2. 1.4 times 2 is 2.8. Then it's 2.8 kilonewtons. Let's move to BG. This is our BG. This is our line BG. It's the same as CI. It's 1.4. You multiply it by the given scale, which is 2. Then it's going to give you 2.8. Then you write it here. 2.8 kilonewtons. Let's move to member GH. This is our GH. So we are going to measure the line GH. Line GH is 3, and then we'll multiply it by the scale, which is 2. Then it's 3 times 2, which is 6. GH is 6 kilonewtons. Let's move to HI. This is our HI. We are going to measure HI and multiply it by the given scale of 2. It's also 3. It's 3 times 2, which is 6. 6 kilonewtons. The next one it's IJ. The next one is IJ. Let's measure IJ and multiply it by the scale. IJ. Let's measure IJ. It's also 3. We multiply it by the scale, which is 6. The scale is 2. It's 3 times 2. The answer is 6. 6 kilonewtons. The next one is HE. HE, horizontal. Let's measure HE and multiply it by the scale. HE, it's also 3. It's 3 times 2. Then HE is 6. 6 kilonewtons. Next one, it's AF. This is our line AF. It's vertical. Let's measure AF and multiply it by the scale. AF, it's 5.5. You multiply it by the scale, which is 2, and then it's going to give you 11. Back to our RL. AF, it's 11. 11 kilonewtons. Okay, now let's check GF. This is our GF. So our GF, it's 3, and then you multiply it by the 2, the scale, then it's 6 kilonewtons. So now we move to DJ. This is our DJ, vertical DJ. Let's measure DJ. We've is 5.05. We multiply it by 2. So 5.55 multiplied by 2, it's 11.1. Then our GF, our DJ, it's 11.1. The last two, it's EF. There is no line EF. They both share a point, so we are unable to find the magnitude of EF. Then if it's like that, you write redundant. The last one is EJ. On our force diagram, EJ shares a point. They both share a point, so we are unable to find the magnitude of EJ. It's redundant as well. Redundant.